Hi, I'm Dr. Pierce, and welcome to this first video on graphing. Before we get started, it's worthwhile to chat about why we bother graphing in the first place. The reason why we're going to graph is to really make sense of the data that we produce from an experiment. And in a real way, a graph is simply a model or a representation of that data for the purposes of simplifying and clarifying it. So if, for example, we take a look at this data here, you can see there's an awful lot of it, and it really doesn't make a whole lot of sense just by looking at it in a table. But if you were to process that data and graph it, you come up with something like this, which is a much clearer idea of what's going on in the experiment, and you can do further analysis from that. But before you actually make your graph, you kind of have to choose which one you're going to make. And it's an important decision because there's a lot of different ones out there. So that's what this video is going to be about. So I'm going to introduce you to a number of different types of graphs that you might produce. So the first one here is a simple line graph or an XY scatter plot that you can use. The second one that's quite popular is a bar graph or a column graph. And the third one is a pie chart, which you'll have seen in many different situations. Some of the ones that you might not use as often, but are still good for biological purposes, is a histogram. The next one is another line graph or XY scatter plot, but this one's actually got two different y-axes on it. And then the final one that might come in handy is a stacked bar or stacked column graph. So those are the basic ones that we have at our disposal, and I'd like to go through each one briefly. So let's take a look at probably the most popular one, the line graph or an XY scatter plot. This is usually used when the x-axis or the independent variable is continuous or numerical. So you can kind of see this situation here where the temperature is a numerical value, and that means it's continuous. There's everything from 10 degrees to 26 and everything in between. The benefit of something like a line graph or an XY scatter plot is it allows you to put a trend line on the graph, and this is helpful to see what's going on in terms of trends, but it also allows you to interpolate data off of it. So for example, in this case, if we wanted to know or predict how much money you'd make when the temperature was 21 degrees, you would simply draw a line up to the line of best fit or the trend line and then over to determine that you're looking at about $480. So that's another benefit of an XY scatter plot. The second one that's quite popular is the bar graph or the column graph, but in this case the x-axis or the independent variable is a discontinuous or discrete categories. So for example, here we've got countries down in the bottom. The thing is with a graph like this is you don't want to put a trend line on there because there's nothing in between Japan and New Zealand. So it's not New Zealand. There's just no such thing. So you would never draw a trend line on there because there's nothing to interpolate. The other benefit of a graph like this is the opportunity to add a second category. So we might, for example, also plot per capita energy use of each country, and you could do that as a second bar of a different color right beside it. So that gives you a few more options as well. In the case of a pie graph, a pie chart is similar to a column graph in terms of it's got discrete categories, but in this case, you're looking at parts of a whole. And the pie graph will be usually presented with percentages, although in this case there are no percentages here. But you can certainly do that, and that shows you some more data as well. So histograms can be used to show a frequency of distribution. In this case, the x-axis is also continuous data, but the difference here is that x-axis data is put into bins or groups. And so what we see here is we've created bins of 10 points each along the x-axis, and then we can show how many students got between 50 and 60, how many got between 70 and 80, and so on. The thing that separates this from a column graph, though, is because the data is continuous, the columns actually touch, as opposed to in a regular column graph where they're separated. In the case of a line graph with two y-axes, you would use this when you're trying to take two different dependent variables that you've measured in response to a single independent variable, plot them on the same graph. So you've got two different y-axes. So in this case, you've got the weight of a person as well as how far they've run over a number of days. And so that can be also useful for comparative purposes. The last one is the stacked column or bar graph. And this is kind of a child of both pie and column charts. So for example, it's part pie graph because what you've got in each column is parts of a whole. So in this case, the different parts are the types of junk food that people are eating. Okay, it's part column graph because you still have discrete categories into which those that data is put. In this case, you're looking at the seasons. So you can present this as both raw data or whole numbers like we have over here in terms of sales, or you can put it as a percentages like it's done here. Same data, just shown in a slightly different way, which can be helpful. So that's a look at some of the graphs that you might use. So when you are presented with data, either from a previous experiment or an experiment that you've done yourself, the first thing you need to do is look at that data and decide what kind of graph you want to make. And as Yoda would say, choose wisely. Thanks for watching.